Hello, wish you have a good day. Thank you for watching program eBelajau Mathematics Form 4. I'm your teacher for this section. I am teacher Tia Pauline from SMJK Notre Dame Convent, Malacca. The learning standard for this section is 6.2. System of linear inequality in two variables. Hence, at the end of this section, you are able to represent situation in the form of system of linear inequality. Let us start with discovery. What is the meaning of system of linear inequality? Please pay attention of the situation. From the given information, it has related two variables that are bars, which can be represented by variable x, and fan can be represented by variable y. Next, we are able to form more than one linear inequality, such as the total number of passengers carried by bus and van as the sum of 32x and 8y is not less than 150 packs. Other than this, the total mass of luggages can be also written as the sum of 350x and 100y is not less than 2000 kilograms. Furthermore, the maximum number of bars can be represented by maximum of x is 4. Conclusion, a combination of two or more linear inequality is known as system of linear inequality. Next, it is the turn for us to determine the appropriate inequality for a certain situation. Check to the given table. The table shows us 12 examples of situation, and each situation can be represented by a linear inequality. Before we start to fill in the linear inequality, let us recall back our previous knowledge. Do you still remember what is the symbol of greater than, less than, greater than or equal to, less than or equal to? Well, after we recall back all these symbols, we can start to fill in the linear inequality. First example of situation, y is greater than x. This is simple. Do you remember how to fill in? Just use your pen. Let's check. Do you get it right? Example number 2, y is less than x. Do you get the answer? Let's check. Well done if you get it right. The third example of situation sounds that y is not less than x. It will carry a meaning y is always greater than or equal to x. The fourth example, y is not more than x. Well, it will carry a meaning y is always less than or equal to x. Let's check for the fifth example. Y is at least k times x. K times x can be represented by a formula kx. Then y is greater than or equal to kx. The next sixth example, y is at most k times x. So we can write it as y is less than or equal to kx. How about the maximum of y is k? Maximum of y means y is always not greater than k or equal to k. Means we can write it as y is less than or equal to k. Next, minimum of y is k. We can write it as y is less than or equal to k. How about sum of x and y is greater than k? We can write sum of x and y by x plus y is greater than k. Then, difference between y and x can be written as y minus x is less than k. The last example or situation, y is more than x by at least k. Y is more than x can be defined by y minus x and always greater than or equal to k. In this slide, we are going to do some practicing on how to write the linear inequality that satisfies the given condition. You may refer to your textbook page 166, example 7. Please read the example. From the paragraph, you can notice that variable y is referring to the number of Form 4 pupils, and the variable x is referring to the number of Form 5 pupils that participate in the camp. Then, please pay attention to the condition A. It stated that the total number of participants for the camp is at most 40. The keyword here is the total number of participants and at most 40. Well, the total number of participants can be represented by x plus y. And the word at most 40 carry the meaning is always less than or equal to 40. Do you know how to write it? Let's check. Next, we go for the condition B. The number of Form 5 pupils is not less than the number of Form 4 pupils. The number of Form 5 pupils is represented by variable x. Well, the number of Form 5 pupils is represented by the variable y. Not less than means x is always greater than or equal to y. Condition C. At least 15 Form 4 pupils participate in the camp. Form 4 pupils is represented by y. At least 15 means you are always greater than or equal to 15. This is the answer. In this question, there is one indicator. We can be checked variable x and y is referring to quantities. Quantities cannot be negative value, hence the x and y is always greater or equal to 0. Well, we can go for the next. Here is the next example, example 8. From this example, we also notice that the question is related to variables, that is variable x and variable y. Both variables are represent the number of refilled ink. Hence, that's referred to quantities. Condition A. The total number of ink ordered does not exceed 25 units. Well, the total number of ink can be represented by x plus y. Does not exceed 25 units can be represented by is always less than or equal to 25. Condition B. The number of ink of brand Y is at least twice that of brand X. Hence, we can represent by Y is always greater than 2x. Condition C. The number of ink brand Y is not more than 8 units. How to represent it? the y is always less than or equal to 8. Condition D. The total purchase does not exceed 400 ringgit. This question is related to cost. Hence, we can use this 14 ringgit and 80 ringgit as the constant number to time variable x or y. The answer will be 14x plus 18y is always less than or equal to 400 ringgit. So practice 6.2a. You may refer to the textbook page 166. Question number 1. In this question, it is also related to variable that is x and y. Condition A. The total number of shirts brought is not more than 50. The keyword for this condition is total number, not more than 50. Well, we can represent by linear inequality x plus y. To represent the total number, not more than 50, can be written as less than or equal to 50. B. The number of shirts of brand X is at least twice the number of shirts of brand Y. We can represent by X is always more than or greater to Y. Or it also can be written in vice versa format. That is, 2y is always less than or equal to x. Condition C. The total purchase does not exceed 550. It related to the cost. Hence, we have to times the concept, that is 8 for x and 12 ringgit for y. We can write as 8x plus 12y is less than or equal to 850 ringgit. Question number 2. In this question, it is also related to two variables, that is x and y, which are referring to the number of pair of shoes. Condition A. The maximum production of shoes is 500 pair. The production related to shoes x and shoes y. Hence, we can represent the linear inequality by x plus y is less than or equal to 500 pairs. Condition B. The number of sports shoes for children is at most 3 times the number of sports shoes for adults. We can write as x is less than or equal to 3y, or vice versa, that is 3y is greater or equal to x. Condition C. The minimum production of sport shoes for adults is 200 pairs. Well, the shoe of adult is represented by variable y. Is always greater than 200 pairs. So we can write it as y is greater than or equal to 200 pairs. Question number 3. In this question, it is related to plants, that is green chili and chili padi. But the question didn't assign any variable for green chili and chili padi. Before we started to write the linear inequality for each condition, we can define the green chili as a variable x or any other variables that you like or prefer. Then I also assign the chili padi as variable y. Condition A. The total number of chili plants can be grown is at most 250. The keyword for this condition is the total number can be represented by x plus y. And at most 250, it means that x plus y is always less than or equal to 250. Condition B. The number of green chili plants is at least 3 times the number of chili plants. We can represent by the linear inequality as x is greater than or equal to 3y. It also can be written as vice versa format, that is, 3y is less than or equal to x. Condition C. The minimum number of green chili plants is 100. We can write as x is always greater than or equal to 100. That's all for my presentation. Thank you for watching. Bye.